Hi, we're going to do 4.2, so here we go. Okay, 4.2 is division with exponents, and so they had already given us 3 properties of exponents, 3 rules of exponents, if you will. And I said, hey, let's discover the rules as we go along. And so this one's called the quotient rule. And if we just use the definition here, x to the 5th means x times x times x times x. One more, right? And x to the 3rd means x times x times x. And then when you start dividing these, x divided by x is 1. And x divided by x is 1. And x divided by x is 1. And then all of a sudden I've run out of x's in the denominator, and it leaves x times x, right? But using the definition going backwards, this way on the definition, this way on the definition, that remember we count, right? I have 2 of them, so that's x to the 2nd. And I bet you could think of a way, besides using the definition forward and backwards in my division rule, that I could get from x to the 5th divided by x to the 3rd to x to the 2nd. And that rule that you're saying is the quotient rule. And what it is that you take the same base and you subtract the numerator's exponent minus the denominator's exponent. And that's your new exponent. So here it's x to the 5 take away 3 is 2. So on problem 21 out of your textbook, we have x in the numerator and x in the denominator, and so we would subtract. The quotient rule applies. 10 take away 4 is 6, x to the 6th. And that's all there is to it. Here there isn't an exponent, but really there is. It's 1, right? And remember what the quotient rule says is you write the base down, which is 8, and you subtract the exponents. 7 take away 1, which is 6. So this is 8 to the 6th. And I imagine that 8 to the 6th is a pretty big number. If it's over 1,000, then I'm okay to write it in exponential notation. And if it's under 1,000, then I need to write it in regular notation. But I'm imagining that that's going to be over 1,000. And it is. It's 262,144. It seems like I've had that number before somewhere. And so I'm okay to leave it in exponential notation right there. And then another property, property 5, is the quotient to a power rule. And so all the rules yesterday in 4.1, not yesterday and today, but in 4.1 all started with a P. The product rule, the power rule, the product to a power rule. And so far our rules are all starting with a Q, right? The quotient rule and quotient to a power rule. So anyway, using the definition, this would be x over y divided times x over y times x over y 4 times, because the definition says count them, 1, 2, 3, 4, right? The definition going that direction for exponents. And so this is just our numerator, right? When you multiply those together, you get a count, 1, 2, 3, 4, x to the 4th. And on the denominator, 1, 2, 3, 4, right? That's how you multiply fractions together, is you reduce, if it will reduce, and then multiply the numerators and multiply the denominators together. And so I bet you can think of a way of getting from there to there, except for not having to go here, right? And so it's that the power applies to the numerator and the denominator. And so this is a to the n divided by b to the n. And that's very similar to the product to a power rule. And then I want you guys to recall from the definition that, and we talked about this when we talked about the definition in 4.1, that the definition did not address what to do if your exponent is the n, was 0 or a negative or a fraction or a decimal. Now we're going to deal with what if it's 0 right now. And in a minute, we're going to deal with what if it's negative. And if it's a fraction or a decimal, we're going to deal with that in chapter in the future. I'm not sure if it's 8 or 9. And if you told me it was 7 later on, I'd say, oh, okay, sorry. And so now, what should b raised to the 0 equal? And so you might have your ideas of what it should equal, and what the people that were developing the math, right, said is, well, let's see how it affects the product rule. So what if I had, so this is essentially b to the 0, any base to the 0, but they're saying x to the 0 here. So what if I had that times x to the 3rd? Well, according to the product rule, this would be x to the 0 plus 3, which is equal to x to the 3, because 0 plus 3 is 3. And so what thing, when you multiply it by something, x to the 3rd in this case, do you get back exactly x to the 3rd? You get back exactly itself. And so I know that we called that x to the 0. But that's what happened, right? I got back exactly x to the 3. And so I'm asking you, what, when I multiply it by x to the 3rd, do I get my answer? And so if you're bothered by the x to the 3rd, let me ask you this with just a number, with 4, say. What do you multiply by and you get back 4? Well, what do you multiply, let's say 7 by, and you get back 7? What is that thing that when you multiply it by, you just get the same thing that you multiplied? What is that guy? Yeah, that guy's 1, right? And so that's what I am suspecting that x to the 0 must be. It must be 1. That's how it just acted, right? And so let's try it with the quotient rule. Well, the quotient rule says you take the base and you write it down and you subtract the exponents. 3 take away 0, and I get x to the 3rd here. And so I'll ask you again, when you take x to the 3rd and you divide it by something, you get exactly x to the 3rd. So what are you suspecting that you're dividing by? 1, right? And so the founding people of mathematics, the founders, I'll call them, they said, you know, what should this be equal to when I have a base raised to 0? And then they started looking at some of their other rules, and they're saying, well, how does it behave? How does the base and the exponent behave? Well, it behaves like 1, right? And so they said, well, by definition then, as a definition, this is the definition, any base raised to the 0 is equal to 1, as long as your base is not 0. And so if you're wondering, well, what would 0 raised to the 0 be? Well, you're going to learn about that in a future semester, not in my class. It's indeterminate is what it's called, and it's something different. So as long as your base is non-zero, and they don't try to trick you with that. So 10 to the 0, I know, it's funny, it's 1. And you can do 10 to the 0 on your calculator, and your calculator knows all about it, raised to the 0. And so it says, yep, that's 1. So 10 raised to the 0 is 1. And then 2ab a squared b raised to the 0. It doesn't matter how complicated it is. We're assuming that the base here is not 0. So the base, this is equal to 1. Yeah, it's kind of funny. And then they did the same thing with negative exponent. They said, well, what should it be if we have a negative exponent? They said, well, what if you did it using the definition? And so I want to think about this using the definition. So this is x, that's what x to the 3rd is, x times x times x. Oh, I want to go this way with the definition. Over here this way, because I just want it on a particular side. It doesn't really matter, but just for my demonstration, I wanted it on a particular side and I forgot. So when I start dividing here and I get 1, and I start dividing here and I get 1, and I start dividing here and I get 1. And so in the numerator I have 1, and I've run out of division, right? And in the denominator I have xx, which by the definition is x squared. Now what if I was to have used the quotient rule? The quotient rule says, so I'm going to go the other way and take the quotient rule, and I'm just showing you that this is equal to two different things depending on what I use. If I use the definition, it's equal to 1 over x to the second. If I use the quotient rule is write the x down and subtract the numerator exponent minus the denominator exponent, which would be 3 take away 5. And 3 take away 5 is negative 2. So in that way, in this example, I've created a negative exponent. And by the definition, we can see what it ought to be equal to with a positive exponent. So that's how they defined it. It makes fraction, it makes reciprocal is what it makes. And so, and we're going to practice that, don't worry. B raised to the negative n is equal to 1 over b to the n. And we're going to practice that. So they say that things are simplified when, and so no parentheses appear, no powers are raised to powers. Each base occurs only once, no negative or zero exponents appear. When the base is a number, like 5 to the third, you write it as 125, whereas if it's 2 to the 100, you just leave it as 2 to the 100. You write in exponential notation if in regular notation the number is under 1,000, right? So 125 is under 1,000, so I should write it in regular notation. Okay, so we're going to try some of these. So this is number 6, is not simplified because it has negative exponent. So they say, well, you need to fix it. And so we're going to use our negative exponent rule, which remember it said this, b to the negative n equals 1 over b to the n. In this case, this is going to be 1 over, our base is 3, and our exponent, make it positive, is 4. So we just use that rule right there. And 3 to the 4, I know what 3 to the 4 is. That's 3 times 3 times 3 times 3, which is 81. And 81 is not a big number. It's not over 1,000, so you should not write it in exponential notation. You should write it in regular notation. So this is 1 over 81. If you're thinking, I bet my calculator doesn't know that. Your calculator actually does know that. 3 raised to the negative 4 is 1 over 81, right? So it also knows that it should be written in regular notation, and it should be written as a fraction. It also knows that. Number 22 is not simplified because the base x appears more than once. And I can use, if I like, the quotient rule to fix that. And so this would be, if I use the quotient rule, right, x to the 4 take away 10, which is x to the negative 6. And now it's not simplified because it has negative exponent. So then I can use the negative exponent rule, which is this rule, write it over 1, right? So this would be 1 over x to the 6th. And so exponent 6, I'm going to write that a little bit bigger. 1 over, and then x to the 6th, and write my exponent a little bit smaller. So this is 1 over x to the 6th, and there we have that one. This one's not simplified because this base occurs twice. 2x is the base, and it occurs twice. And also because of negative exponents. So there's more than one thing that this one's, reason that this one's not simplified. So I certainly can use the quotient rule, and I can certainly use the negative exponent rule. Whichever one I want to use first would be just fine. And so it's my decision which one that I would want to use, which rule I would want to use first. I could also use the product to a power rule first if I wanted. That would be another rule that I could use. So it's my decision on which one of those I would use. So probably what I would do is I would probably get rid of the negative exponents. And my office mate, Raphael Espericueta, when he was my office mate 100 years ago, he used to say that the negative exponent, that to write it, he said that you think of it as a fraction, like it's an upstairs and a downstairs. So I just want to show you how he thought of it. And then if you're at the upstairs party and you have a negative, then you go to the downstairs party, right? And so this would go to the downstairs party and then leave nothing in the numerator, so you need the placeholder 1. And so that certainly worked with this as well, right? Went to the downstairs party. So this is unhappy at the upstairs party. So Raphael would say, and it's basically this negative exponent rule, but it's kind of a shortcut or a short way of remembering it. You could write that in the downstairs party, and you would do the same here. So now they have positive exponents, and now I could choose to use the quotient rule if I want, and you would get the same answer if you'd use the quotient rule from before, but it just is less likely to make a mistake, because when you take 15 take away 10, most everyone gets 5. So this is 2x to the 5th, and then this is not simplified because it has parentheses, right? And so this is 2 to the 5th and x to the 5th using the product to a power rule, and 2 to the 5th is 32. So all said and done, this is 32x to the 5th. So 2 times 2 times 2 times 2 is 32, and then that's our answer. Now you certainly could have gone from here, and used the quotient rule, but a lot of people mess that up, because you would be writing your base down 2x, and then you're going to subtract negative 10 take away negative 5, so negative 15. So that would have been a way of going, and see how this would have been add. So that would have been negative 10 plus 15, which is 5, and we get 2x raised to the 5, and then yada yada, right? We already did that. And so you certainly could have done it that way first if you would have liked. But you could have done this too. So this is way number 2, right? But it leads us to this, which then leads us to the answer, right? Now, way number 3, that would have been okay, would have been to use the product to a power rule, 2 to the negative 10, and x to the negative 10, and 2 to the negative 15, and x to the negative 15. And then you could have used the quotient rule here, which would have been 2 to the negative 10 take away negative 15, x to the negative 10 take away negative 15, which is 2 to the 5th, and x to the 5th, which is 32x to the 5th, so, you know, etc., right? This works out to now you can see that it's going to be the same. So there are different ways of going, and it doesn't matter. Whatever way you think would be good. Okay, so this one I'm looking at my exponent negative 2, and I probably would use the product to a power rule, and I probably would put an exponent 1 here, just so you can see something. So this would be 5 to the 1 raised to the negative 2, and this would be 4 y to the 4th raised to the negative 2. And do you guys remember that when you have, now that I use the product to a power rule, that when you have 2 exponents acting on something, and there definitely was a 1 there, that they multiply. So this is 5 to the negative 2, and this is y to the negative 8. And now I would want to write those as positive exponents. And so Raphael would say, think of this as a numerator and the denominator. So they're both in the numerator and they're both negative, so they need to move to the denominator. So when they move to the denominator, that's 5 to the 2nd and y to the 8th. And that left nothing in the numerator, so the placeholder 1. And that gives us 1 over 25 y to the 8th. And great answer. Different ways of doing it, but that's one way of doing it. Here, I would use probably the power rule here, and that's 2 times negative 3, so you would multiply those exponents, that's negative 6. And you could use the quotient rule, but I probably would use the Raphael move it rule first, x to the 6th and x to the 5th. That's the negative exponent rule. And the reason is I see people make mistakes with the quotient rule all the time with the negative exponent. And so now I'm going to use my quotient rule. This is x to the 5 take away 6, which is negative 1. Yeah, you would have gotten the same answer. And then this is 1 over x to the 1, which is the same as 1 over x, right? So there's our answer there. And so however you want to go is just fine. Now, not everything moves, and my examples here, for every one of them had something moving around. So I want to make another example, and it was just luck of the draw, and I knew this and I forgot to change it. But if you had this 2 over x to the negative 3, then the 2 is perfectly happy. Its exponent is 1. So it would not move from the numerator. And so this would be 2 in the numerator, and this would move up to the numerator because it's got negative exponent x to the 3rd. And then that would be your answer on that one. And so not everything moves. And so that didn't, the 2 didn't move because it had positive exponent. And anyway, if you had this, so this is another example that I'm making up for my head. Let's say you had 2x over x to the negative 3. Well, now the exponent here is 1. It's positive. It stay put. The exponent is 1. It would stay put. So this is 2x. And then this would come up to the top times x to the negative 3. And then you would put these together. Change the exponent to positive when you move it in the numerator, right? And that would be x to the 4th. 2x to the, add the exponents 4th. So anyway, so there's some different examples where, you know, not everything moves, and so just, you know, the 2 and the x stayed put, and then you can combine like terms with them and whatnot. You guys will practice them. You'll practice them on different things, and you'll get used to it. You'll be good at it. Okay, so scientific notation, some more of it, and we already did one like this, and it's asking me to write it in decimal notation. So I move the decimal point 3 places, right? So 1, here's the decimal point, and I'm going to run out of room. So 1, 2, 3, and the decimal place moves over to here. So this becomes 4, 2, 3, 0 with the decimal here, or you can write that as 4, 2, 3, 0, right? And the reason I wanted to show you this one and this one is that this is because we multiplied by 1,000, and so that moves the decimal point to the right. And but this one right here times 10 to the negative 3rd, well, negative exponent means that's in the denominator. So this is really 4.23 divided by, right, 10 to the 3rd. Make it a fraction, and then it goes downstairs, right, because it has negative exponent. And so this is not multiplying by 10 to the 3rd. This is dividing by 10 to the 3rd. So when you multiply by 10 to the negative 3rd, it's the same as dividing by 10 to the 3rd. And that moves the decimal place the other way. So the decimal, because when you divide by 1,000, it's going to get smaller, right? So you're going to move here 1 and 2 and 3, right? And so your decimal is going to move to here. So this is going to be 0.00423. So I get where I say, oh, negative exponent, I'm going to move the decimal 3 places, but to make it a smaller number. And so anyway, so that's kind of that story. So the directions have gotten on here from the next page, which is convert to scientific notation, right? So that's what the directions were here. I think that it's probably okay on yours because yours was a PDF. Convert to scientific notation. And so this is a number that's really, really small. And I have to tell you that I don't remember right and left with my positive and my negative exponent. What I remember is in regular notation, this is in regular notation, if the number is small, and small is a comparative term, small compared to 1, then I know that when I write it in scientific notation, it's going to have a negative exponent. That's what I remember. And if it's a negative exponent, it's going to be a small number, small compared to 1. And so you see how this one had a negative exponent. So when I got it into regular notation, it was a small number, small compared to 1. Where this one had a positive exponent, and when I got it in regular notation, it was big, big compared to 1. And so anyway, So this one here, I say to myself, oh, I already know it's going to be a negative exponent, and I'm going to move the decimal between the 4 and the 8. So this is 4.8, because this needs to be, in scientific notation, a number between 1 and 10. If I make the decimal anywhere else, 0.48, well, that's too small. That's smaller than 1. If I make it over here, then that's 48, and that's bigger than 10. So there really is only one spot it can go, and that's right in here between the 4 and the 8. And when I move the decimal, it's 1, 2, 3, you count, 4, 5 places. So times 10, and I know that it's negative, negative 5, because this was small number goes with negative exponent when you write it in scientific notation. So I know that it was going to be negative exponent. Whereas this one over here in regular notation, so in regular notation, if your number is big, well, big compared to 1, you know what I mean? So you have to compare it to something, and I compare it to that range 1 to 10, if you like. And so it's big. It's a big number. Then I know that when I write it in scientific notation, it's going to have a positive exponent. So that's kind of the idea. I don't remember right and left. You're free to remember right and left if you like, but since it changes depending on if you're going in or out of scientific notation, it confuses people. The right and the left actually change. And so people who typically are my right and my left people that say you move it left, you move it right, what happens? They typically get it wrong. And so if you just think about it, you won't get it wrong. So if it's a big number, that means you should be timesing by a multiple of 10, right? So this is a big number, and my decimal's there, 4.8, times 10, and we moved it 1, 2, 3, 4, 5 places, and it's positive exponent, so positive 5. And so this is dividing by, what is that, 100,000, is that right? 5 zeros. 1, 2, 3, 4, 5 zeros is 100,000. This is timesing by 100,000 because of the positive exponent. Negative exponent means put it in the denominator and divide by 100,000. Anyway, and then here's just a summary of the rules of exponents. I just thought it would help you when you were doing the homework to have all the rules of exponents written in one place. And so anyway, if it helps you, there they are.